Good morning, everybody. Welcome to another edition of our Aquarium Online Academy. My name is Amanda, and I'm coming to you live from the Aquarium of the Pacific in Long Beach, California, where today we are going to be discussing the deep sea and bioluminescence. I think some of the most fascinating topics there are to talk about. And I would love to hear from you. If you're watching this now during our program and you have some questions and comments, we invite you to text them in. You can use the number that you see on the screen right now, 562-286-1838, and text in any questions or comments that you have as we learn together and we discover more about the deep sea and bioluminescence. Now, if you're watching this at a later time and it's not during our live program on Friday morning at 10 o'clock Pacific time, you can email us your questions at live@lbaop.org on the very bottom, and we will have an educator get back to you. So we still want to hear from you. So as we get started today, talking about the deep sea, I want you to think about the deep sea. What are some things that you know about it? How would you describe the deep sea? What are some images maybe that come into your heads? Maybe something you've heard about it, or something you wonder about it. What is the deep sea like? So any of those things that you'd like to share, go ahead and text in. Again, children, make sure you have your parents' permission, or your teacher can help accommodate this request before you text us. But we would love to hear, what are some thoughts that come into your head? How would you describe the deep sea? Now, I do have a friend here, Tiffany, who is helping me control everything that you'll be seeing on the screen. She's on the other side of the camera. She'll also be responding to the text that you're sending in, and she can let me know what you're sharing. So thank you, Tiffany, for your help today with this. So let's go ahead and bring up a picture of the deep sea and see if that conjures up any other images you might have. Now, when you look at this picture, this is coming from the NOAA Office of Ocean Exploration and Research. Do you have any idea what you're looking at here? Well, this place that I'm standing in front of right now, it's really dark. So that's one thing I'm noticing right now is it's pretty dark around here, but there is a light that's coming from this interesting source. But I'm wondering, what kind of source do you think this is? Because what you're seeing in this picture is one of the best ways that we can discover more about the ocean. And I want you to think about what it might be and why would this be an important way to discover about the ocean? Because if you think about discovering and what kinds of tools that we use when an explorer goes out and explores a new area, what are they using? What's available to them? Well, we have certain things in our body that are available to us. We use our eyes to make observations, which of course I'm asking you to do right now too. But then there's other things we can, if you're talking about the ocean, we could go swimming in the ocean and, see what we can see. But is this an area that we can just swim down to and look with our own eyes and see what's going on? What would be some limitations to exploring in the deep sea? So think about that, and then think about why this might be important and what this is and how I got there and what its purpose is. I'm going to have you think about that for a second. All right. So hopefully you have some ideas in your head. And of course, you can just shout them out at the TV screen. I may not be able to hear you very well, but you can participate in any way you'd like if you're not able to text in. So as you go down deeper in the ocean, there's a few things that happen. Have you ever swam to the bottom of a swimming pool? Have you? What did you notice happening? Were there any changes on your body? Anything that felt different from the top to when you went down to the bottom? Well, if you're like me, you may have noticed some changes in your ear. You feel this pressure on your ear because as you go deeper into the ocean, the pressure increases. So that is a really big change between the surface and the bottom of the ocean. But wait a minute, how deep is the bottom of the ocean? If I'm talking about going to the bottom of a swimming pool, it might only be like 5, 8, 10 feet deep. So not really deep, but I can still feel changes in pressure after going down just a little bit. Well, how deep do you think the ocean is? What do you think the average ocean depth is? Because oftentimes we know, well, it gets deeper as you go further from shore, right? Yes, it does. In fact, the deepest part of the ocean is in the Pacific Ocean. So the Pacific Ocean right off our coast here in Southern California. If you were to go further out, though, into the Pacific Ocean, you might find a place called the Mariana Trench. And the Mariana Trench is the deepest place in the ocean. And it is so deep, in fact, that you could take Mount Everest, our tallest mountain on our planet, and you could put it inside the Mariana Trench, into the Challenger Deep, the deepest trench, and it would still be covered with water. That's how deep it is. It is over 35,853, I think is the deepest someone has gone, but is over 35,000 feet deep. That is really deep. But the average ocean depth is about 2 miles. Now, 2 miles is pretty deep. Have you ever had to run a mile at school? Maybe you have. Well, imagine running 2 miles straight down into the ocean. That's how deep the average ocean depth is. So that means some areas are shallower, some areas are deeper. But think about how much pressure you would feel on your body if you were to swim down that deep. So that's one of the reasons why people can't just swim down. You can't put on scuba gear and go down and explore the deep sea. So we need to use other tools. And what you're looking at here is a very special tool. This is an ROV. I believe this is an ROV. There's 2 different ways people can explore. They can explore in manned submersibles, which means they're actually sitting inside a submarine and they're going under the water and they're exploring. And there's protection around them so that they're not feeling the pressure of the ocean directly on their bodies that our bodies wouldn't be able to withstand. But then you go deeper still. Well, you can even use ROVs, which are remotely operated vehicles. That means nobody's actually sitting inside of it, but you can control it, maybe sitting up on top of the ship at the surface of the ocean. And you might be using like a remote control, like a video game. Do you like to play video games? Well, you might be perfect for ocean exploration, because if you can control a video game, maybe you could control an ROV to explore the deep sea and discover things that no one has seen or discovered before. There is so much in the ocean that is yet to be explored. About 90% of our ocean has yet to be explored and discovered, which is pretty amazing because there is so much depth to the ocean. We're not just looking at the outside, at the surface of it. There's so much is going on below. So this gives us insight into what might be going on in areas where we couldn't travel ourselves just because the pressure being too great on our bodies. But as we are to go deeper in the ocean, there might be so many other exciting things that we could explore. And I think one of the most fascinating things about the deep sea are the organisms that live there and what they can do. Because we notice that it's very, very dark right here. So where is the light coming from? Obviously, the light is coming from this ROV in this picture. But without this ROV and without this outer source of light, it's completely dark. Now, we are familiar mostly with the animals that live in the top layers of the ocean in what we call the epipelagic zone, like the top layer, like your epidermis on your skin is the outer layer of your skin. The epipelagic zone is what we call the photic zone, where the light is coming in and how far the light can reach into the ocean. And most of the animals we're familiar with live in that top layer because light is so important for life. Can you think of any reasons why light might be important for life in the ocean? Well, is light important for us? Is it important for plants? And why would it be important for plants? And then, therefore, why would it be important for us too? Well, plants do something very important with that light. They take the energy from the light and they create oxygen through the process of photosynthesis. And that's something that we need to breathe. Well, that process happens in the ocean as well. And it happens in the big plants and the big algae, like things like kelp, but also in some very, very small things in the ocean, in plankton. So there are plankton in the water, little tiny plants that are actually collecting energy from the sun. And it's really important. They need that light to produce oxygen to help the other animals in the ocean survive, as well as, we benefit from it too. In fact, most of the oxygen we breathe is produced by plants in the ocean from phytoplankton. Now, I mentioned there being plants in the ocean that are really tiny, but then there's also some other animals in the ocean that are really tiny that eat those phytoplankton, and these are the zooplankton. These are the animal plankton that are in the water. So this is a view that you would get under a microscope. So there is so much life, just the water is teeming with life in the ocean that we don't even see or think about most of the time. But there are little tiny plants and little tiny animals that you would have to use a microscope to see. And now the plants produce oxygen, and then the animals might move around and eat them, the little zooplankton here. But then there's also something else, and they're called dinoflagellates. And dinoflagellates are more like plants that can swim. So they're really interesting organisms. They're protists. They're usually they're single-celled organisms that float around in the ocean, really, really tiny, just like all the other plankton. And they do something that's incredible. If you've ever been to the beach and you've looked at the beach at night and you've thought, wow, it looks like those waves, it's almost like they're glowing. It's so magical. It must just be the moonlight making it appear beautiful. Well, it's not just the moonlight. So recently, I don't know if this year we've had any, but last year we had an incredible display of lights in the ocean. Now, you might notice there's some lights up here. This is in Long Beach. But then if we look at the wave of the ocean, it's not just a regular ocean wave. There's something else pretty interesting that's happening there. And those waves were glowing. Now, how are they glowing? What kind of organisms do you think might cause the waves to glow? Because the waves by themselves, they're not living things. The water isn't a living organism. Let me get out of the way. Let's watch and see if you can see any more glowing waves. I have to be patient. Oh, there's some out here. Then we're going to get that big wave that's going to come up. Here we go. Wow, look at that. So it's this bright blue color. How is that happening? Do you know what it's called? It's actually coming from living organisms that are in the water, and those living organisms are creating their own light, and that's called bioluminescence. So it's a living organism, that's the bio, and luminescence is the light. So how and what are these little organisms creating this light? Let's explore that a little bit more. So the dinoflagellates have something called luciferin. It's kind of a weird word, but this luciferin is a molecule in their body. Then there's something else called luciferase, which is an enzyme. And you put these things together in the presence of water, and you can get something called, well, actually it doesn't really matter. The extra thing, oxyluciferin is what you get. But the exciting part is you get light. So it can actually produce light. So what you're seeing right here are these little tiny dinoflagellates, these little tiny plankton that are creating light. But why? Why would an animal want to have bioluminescence? Well, in this case, this picture, we just see it happening in the waves. They're being stirred up by something. And as that process is stirring them up, it's causing this luciferin and the luciferase to act together to create the oxyluciferin and the light. But why? How is that beneficial? Do you think these animals are trying to see and look around? Well, no, it's a little bit different. We have another picture of a boat that's going through the water. Now, this is not a video like this one is, but we have a picture of someone going through the water in the presence of all these dinoflagellates. And as the boat goes through the water, the waves appear to glow. So what's happening here is as the waves are getting stirred up, these little dinoflagellates are thinking, oh my goodness, is something going to harm me? Well, in case something's going to, because I'm getting shaken up a little bit now, I'm going to try to create a distraction. And maybe that thing will go after this distraction of this light that I've created. And that is kind of what we're getting to see. So notice out here in the water where it's all still kind of calm, nothing's happening, it doesn't look like it's glowing, but there are probably lots and lots of dinoflagellates in that water too. But they're staying calm and not disturbed. But as soon as the boat breaks through the water where these dinoflagellates are, they're like, oh my goodness, there's something there. And I'm going to shoot out my bioluminescence. and maybe it'll distract them and they'll go somewhere else. Now, it's not just dinoflagellates that do this. There are other organisms in the ocean that do this as well, and they use their bioluminescence to maybe help protect them. If they think a predator is coming after them, if they can shoot a distraction this direction and cause that light to catch their attention, that might be one way that they can survive. Here's an example of one of those animals right here. Look at this shrimp and look at what's going on. There's a whole bunch of glowing blue light all around it. And this shrimp is one that is known for basically spewing this spray of bioluminescence. And you can see kind of this progression of how it all just spews it on out, spits out this cloud of bioluminescence. And scientists believe it is to distract whatever might be trying to disturb or eat that organism. And so the animal can get distracted by that blue light so that the shrimp can get away. But can you think of any other reasons why an animal might use bioluminescence? Well, as we're thinking about that, let me show you what it looks like in our classroom. If you wanted to look at bioluminescence without having to go into the ocean, the deep sea, on just the right night at the right time, we actually have been able to see it in a classroom here by looking at something called an ostracod. Now, an ostracod is a little tiny organism, little type of zooplankton, actually, which are the animal plankton we were looking at that were moving around all over the place. Here's an ostracod. They're also called deep sea fireflies. And the reason they're called deep sea fireflies is because they can create bioluminescence, which is also what a firefly uses when they are getting ready to light up. That light that you see from a firefly is from bioluminescence. So this is it. These are these little tiny, you can't really see them very well, can you? These little tiny specks that we put into this little bowl, this dish, that are just these dried out, so they're not alive anymore, but these ostracods, they're really tiny, they just look like specks. And then when we mash them up and we add some water to them, we get to see something really neat when we turn out the light. So we turn out the light in the classroom and we went ahead and recorded this for you so you can see. So, okay, so there's our ostracods. And then my friend Stewie took a pipette with some water in it, and he adds water. And look at what happens here. You see that? So now we're looking inside that dish, but we've added some water. There's the pipette that he's using right there. And look at that. All of this. And he's just stirring it around. So these things are not moving on their own. That's just as we stir it. But as it's as that or as the luciferin and the luciferase are coming together in the presence of the water, we're getting really cool glowing bioluminescence. And that is coming from just the mixing of everything, which is what these organisms are doing. Oh, here we go again. What these organisms are doing inside their bodies. And unlike if we turn a light bulb on and we often get heat that's associated with turning on light, bioluminescence is what they consider cold light. It doesn't release a lot of heat. It actually is kind of cool as it lights up. So here's that close-up picture of that ostracod again. Very strange looking organism, but it is a live organism that produces bioluminescence. So we know that they do it for distraction and for helping them to survive. But what about some other reasons an animal might use bioluminescence? Can you think of anything? Imagine life in the darkness. How would it help an animal to be able to light up? Can you think of any reasons? Maybe you might be thinking in your head of a movie that you saw once about a little clownfish and its friend. So have you ever heard, well, actually, before I give you too many ideas, we're going to show you a picture. Maybe we can pull up a picture that might include, if Tiffany has any idea what animal I might be talking about. There we go. Look at these lovely creatures from the deep sea. Wow, what do you think of when you look at these? Do these look like they could all win beauty pageants? Maybe not the prettiest looking fish, but there are some really interesting adaptations that they have. So the things that help them to survive. I want you to look at their bodies and see if there's anything that you notice about their bodies and what stands out to you in each of these pictures. And again, you're welcome to text in any comments that you have too. But look at this. What do you notice about this animal? Ooh, there's this crazy thing here. What about this animal? Hold on, it's kind of weird. Oh, ooh, what is this? And then this one, whoa, it's kind of a big eye and a big patch right there. This, can't even tell you what this one is. This looks so strange. This, hatchet fish. Interesting. What do you notice? See lots of these light sort of areas in its body. Oh, here's another thing, a long thing extending out. Oh, and here's another one. And this has something funny hanging from the top of its head. What does that look like to you? Well, we would call this a lure. So this is what an anglerfish uses as a lure. And if you've ever heard the word angler, an angler is a fisherman. Someone who uses a lure to attract fish. Well, that's exactly what an anglerfish does. They use a lure to attract food. So they can kind of weigh this out in front of them, and if it can light up in the darkness where everyone else is just seeing just darkness and black, if something lights up that it catches their attention, it's going to maybe draw some food over closer to the anglerfish. Now, the anglerfish is probably not the fastest swimmer in the ocean. I don't know. We can't really see its whole body here. But they tend to be kind of robust and not looking like they're terribly fit. But they do try to take advantage of whatever might come close to them using that bioluminescent lure. And then they can use those big teeth that you see there to kind of trap and grab a hold of that prey, take advantage of them coming close so that they can find a nice meal. So bioluminescence could be used to attract prey to an animal. In fact, I don't even know what this fish is called, but I'm noticing this long thing coming from its body. What might they use that for if they live in the deep sea? Well, maybe it's something that helps them figure out and feel around. Maybe they're like feelers. They stick out a lot longer than these fins do on their body. Or maybe that can bioluminesce and light up, and they can attract something over to it that way. So that could be another lure. This one looks like another lure to me. So definitely, bioluminescence can be used to attract things over. Oh, also this one has that crazy thing sticking out from under its chin right down there too. But are there any other reasons that lighting up could be useful to an animal in the ocean besides finding food or attracting food over to it? Do you think maybe they could use their bioluminescence to find food? Well, believe it or not, some of them can. I don't believe we have a picture of it. I don't even know what this animal looks like. But I do know that there is a fish called a black moose jaw that has the ability to do something unusual that these other fish don't do. It can light up with a red light. So all these other ones, have you noticed the color is kind of this blue color? And the bioluminescence we were looking at in the classroom and in the waves, it was a blue color. And that blue light is important in the ocean because it travels really well and other animals can see it. They can see blue really well in the ocean. Now, if something was red, it's actually not going to be able to travel all the way down to the bottom of the ocean. You might wonder what I'm talking about. Well, if you think about the light that comes from the sun, it's all white light. It's a combination of all these different wavelengths of colors. Red, orange, yellow, green, blue, indigo, violet. You've heard the colors of the rainbow. Well, how are we able to see rainbows? We're able to see them because a prism, maybe it might be a droplet of water acting as a prism, can actually refract or bend the wavelengths, the different wavelengths of light. Those different colors are all different wavelengths. Some are long, like the red wavelength is a very long one, and some are really short, like the purple one, the violet. Well, those wavelengths travel at different strengths through the water. They all travel pretty well through the air, but when they hit the water, that's where things get a little tricky because the red light isn't very strong and so it doesn't travel very far. That means if something is colored red at the surface of the water, we will see it bounce off that object and that red wavelength will travel back to our eyes and we will see the red color. However, if the red wavelength can never get to that object and it can't reflect back the red color to us, it's going to appear dark. It will look maybe like a black color. So a lot of animals in the ocean, believe it or not, have a red color. Not so that they stand out easily to other animals because there's no light down there, but it actually makes them easier to blend in if they're in that area where there's a little bit of light coming through. You might be able to see other things. You won't be able to see those objects, those animals that are red in color. Okay, so let's get back to this black moose jaw. This black moose jaw fish can create a red color. And you think, well, why is that important? Because a lot of animals actually can't even see the color red in the deep sea, and they've even lost the receptors in their eyes to pick up on the red wavelength because they don't need it. But the black moose jaw can create this red light so that it can see things. It has receptors for the red light, and that means it's like turning on a red flashlight, and it can look around and see everything all lit up with its red light, but nothing else realizes that it's being shined on because they can't see the red light themselves. It's really interesting. So they actually use bioluminescence. They're the only animal I know of that has a red bioluminescence, so they can see other animals in the ocean. It's fascinating that don't realize they're being lit up, like having a flashlight shine in your face. Not a fun thing, but if you don't realize it's on, no problem. But these other organisms have this blue color that they use. So they can use their bioluminescence to help find food. They can also use it to confuse predators. So this little fish, the flashlight fish, we happen to have some at the aquarium. They're very cute little fish. And they have this patch underneath their eye that's actually caused by some bacteria that they have living in their bodies. So the bacteria can create this bioluminescence. And as it's turned on, as the fish is swimming this way, it looks like, oh, it's a nice bright little light going that way. If I'm a hungry predator, I might think if I want a meal, I'm going to follow that light and I'm going to go get my meal. But the flashlight fish has another idea. What it does is it swims this direction with its flashlight on, and then it covers up that flap of that glowing bacteria so it gets dark. And then you know what it does? It swims the other way really fast. And so if you are a predator, you see that light flashing on and off, you think, well, it must still be going that direction. So once that light flashes off, you're still going that way, but what you didn't realize is that in the darkness, the flashlight fish turned around and gone the other direction. I think that's a pretty cool trick that the flashlight fish do. And then if we look at these other things, these lights down here, this is a hatchet fish, and they have bioluminescence on the underside of their body, which helps them to blend in when they go up to the surface. Because if you travel closer to the surface, you're going to start to get where it's lighter. And it's going to be lighter at the top, still dark at the bottom of the ocean. But as you go up closer to where there might be light coming in, if you have light on the underside of you, it's going to help you blend in with that top light. That's what we call counter shading in a lot of animals that don't actually light up, but they're colored darker on the top and colored lighter on the bottom. And we call that counter shading because if you're above the animal looking down to the deep sea, they look really dark and blend in. If they're underneath them and they're lighter colored and they're not creating such a dark silhouette against the sun from the surface, then they blend in better and harder to see. So it's great for predators and it's great for prey. And that's how the flashlight fish uses its bioluminescence on the underside to help it blend in so that it's harder for them to see, because this is a fish that will do what we call vertical migrations, and they will go up and down in the water column at certain times. So we know that these animals can use bioluminescence for a distraction, to distract predators so they can get away. They can use it to lure animals over to them to eat. They could even use it to blend in and not be seen as well. And can use it to even deceive predators and make them think they're going a different direction. They also can use it for communication and finding a mate. So the anglerfish, this beautiful one down here, have been known to actually release pheromones, a smell, to let other anglerfish know in the darkness that they're out there. And then they'll use that little lure to kind of flash it around and attract other males. So it might be a way that they find a mate as well. It also can be used as a signal. We call it a burglar. We have this really cool picture of this jelly. Now a sea jelly, or a jellyfish you might think of it, they're round at the top. This is a top picture of what we call the bell, the top part of the jelly, and it's all bioluminescent. It's all lighting up. And the reason that what scientists have discovered, especially Edie Witter, she discovered that with this lighting up jelly, it might be a signal to other animals if they're being eaten, if something is trying to eat this jelly or it's in distress. if they send out this bioluminescent glow, then other animals nearby might say, hey, if there's something being eaten over there, maybe that's an opportunity for me to go find a meal too. Not to eat the jelly, but it's like the jelly saying, hey, if anyone out there really big is hungry, something really big is eating me. So come over and get it so I can get away. So that's basically what this burglar alarm is, that they can use for communication using bioluminescence. So here we have a beautiful display. Now this is just a still shot. If you were to see the video, they are beautiful, and they have bioluminescence all the way from the center all the way to the outside of this beautiful jelly. So there's many different organisms in the ocean using bioluminescence. About 95%. Sometimes people think, I'm sorry, not 95%, 75% of animals in the ocean, some scientists think could have the ability to bioluminesce that we didn't even know about yet. So I hope you've explored the idea of bioluminescence and thinking about the deep sea and how very different it is than what we experience and what we're used to seeing. But there's so much out there in the ocean to be explored, and so many fun things to be a part of. I encourage you to check out nautiluslive.org. And the Nautilus is actually a research vessel that sends ROVs into the water with special cameras on it that will feed right into your computer. You can actually see them through webcams on your computer at home. So if you wanted to see some scientists that are exploring the deep sea and seeing at the same time they're seeing it, these amazing discoveries in the ocean, you can even type in questions and they will answer them live online as they're making the discovery. So this is what it looks like in the control room of that ship. And you can see some of the really cool screens that they have access to. This is one of the ROVs on the deck of the boat. And then you can actually see from the ROV when it's in the water. So if that's something that interests you and learning more about the deep sea and exploration, and here's one of those manned submersibles that we were talking about earlier. You could actually get into one of these. If you have a chance to do it, go for it, because that would be amazing to explore the ocean as well. But I encourage you to check out more about ocean exploration, and you can get your questions answered directly from the scientists that are doing the exploring. So I hope you had a fun time with me today, and I hope you have a wonderful day. Again, if you have any questions, you can always email us at live@lbaop.org. So have a great day, everyone. Bye.